Okay, so it says up at the top, it says the expression 6x plus 7 has two terms. The expression 9x squared minus 3y plus 7, that has three terms. A number all by itself is considered just a single term. Okay, so given those examples, what are terms? So I want you to talk about in your groups really quick. These are the two things I want you to talk about. What does a term include? So talk about that. And also talk about what breaks terms apart. Okay? Because there has to be some way for us to know that 6x plus 7 is two terms. Alright, so I want you guys to talk about what is included in a term and also what breaks terms apart. Okay? Alright, so go ahead. Okay, so let's start with what is included. So, included. Okay, so what is included in the term? Can somebody raise their hand and tell me one thing that's included in a term? Yes, sir. Numbers, okay, so that's one thing. So we have numbers. What else? All right. What else do we see in the terms? Obviously 6x and 7 and 9x squared and all those terms are not just numbers. What else do we have included in there? Variables. Variables, okay, so we have numbers, variables. Anything else we see? Exponents, good. Okay, numbers and variables and exponents. There are more things that can be included in a term. We're not going to look at, for the most part, these will be our terms. Okay, we won't really look at much other than that. Okay, so now let's talk about how they are broken up. So what breaks up a term? How do we know that 6x plus 7 is two terms? How about this front table? How do we know that 6x plus 7 is two terms? What breaks up terms? Yes, ma'am, you are Mia. Okay, there are only specific operations, and you did say plus, that is one. What else? What other operation? Subtraction, right? Because we see 9x squared minus 3y on the other example. So only plus or minus, because if we see multiplication, that's like 6x is 6 times x, okay? So multiplication doesn't necessarily break up a term, but we have plus or minus breaks up terms. Okay, so now that we know what terms are, let's look at what are like terms. So we have some examples and non-examples here. So it tells us that 6x and 13x are like terms. It also tells us that 32y squared and 1/2 y squared are like terms. Then it also gives us a non-example here, right? It tells us that 3x squared and 3x are not like terms. So given those couple examples and the one non-example, I want you to talk about the two sames that have to be true in order for terms to be like terms. There are two things that have to be the same. So I want your groups to come up with them. Okay, go ahead. Okay, so two things have to be the same. Can somebody give me one of them? Jada. Good, so that's the easier of the two, I think. Maybe. Maybe it was the harder one for you guys. So same variable. Does anybody have the other one? Namely, y, 3x squared and 3x are not like terms. What has to be the same in order for them to be like terms? They have the same variable, they have to have the same exponent. Good. Okay, so it's important we don't just look at two terms and say, oh, 3x squared and 3x, they have the same variable, they're like terms. In order to be able to add or subtract those, to combine them, we have to have the same variable and same exponent, okay? So now let's actually look at combining like terms. All right, so number one, it says adding. You see that there's a plus sign in the middle. We have to be careful. Sometimes there are plus signs in the middle. Sometimes there are minus signs in the middle, and sometimes there are just numbers or variables sitting right next to the parentheses, which would be multiplication. So we have to be careful. We see addition here. I'm going to give you 10 seconds. I want you guys to underline with your groups. Okay, you can either underline one in blue, one in red, if you have notability, or you could underline one and squiggle underneath the other pair. I want you to underline the two sets of like terms in example 1. Go ahead, quickly. Two sets of like terms, underline them. Okay, so my two sets of like terms, same variable, same exponent would be 6x, and what else goes with that? 9x, good. And then we also have 7 and -1. Even though those are just numbers, yes, they are still like terms because we will combine them together, okay? Now, all I have to do, simple as that, I just add them together. I always like to think about fruit, okay? It makes it easy to think about. So if I have 6x and 9x, I think 6 apples, and I add 9 more apples to the bag. So what would I have then? 15 what? Apples, right? I wouldn't have 15 apples. I wouldn't have 15 apples squared. I certainly wouldn't have 15 oranges, right? If I have 6 x's and 9 x's, that makes 15 x's, not 15x squareds, not 15 xx's, not 15 y's, okay? Apples and apples make apples. And then I add 7 plus a -1, which would be plus 6. There are no more like terms, so I'm done. All right, you guys have to try these problems. Go ahead. Okay, you can check your answers on the board. See, on A, I got -6m plus 9. On B, I got 2x minus y. You can do minus 1y. The 1 is optional. If it's there, it's fine. If it's not, it's fine. Questions on those? Okay, let's look at subtraction. Okay, let's look at subtraction. So, subtraction, all we're going to do is make it an addition problem. Okay, so there's just one added step on the beginning. So what if I gave you, over here on the side, 2 minus a -5? How do I get to adding? Because you said I would add. How do I get to adding? What do we call it? Is everybody asleep today? What do we call it when you see two negative signs right next to each other? Okay, so you change, or some of you guys learn bloop, or I don't know, whatever you learn. Okay, change. So I change the subtraction in the middle to addition, and I change the sign of whatever's after that, right? I change. So I'm going to take that same concept, and I am going to apply it to this problem. So now when I see that minus sign in the middle, I am going to change. Okay, so watch what I do here. So I see a minus sign in the middle, so I'm going to make it addition. In order to change that, I have to change everything inside of the parentheses. So what is x currently? What sign is x currently? Positive, so it needs to flip back negative. What is 8 right now? Negative, so I need to change it back positive. So you see how I did that? I changed the sign in the middle, and I change every sign afterward. I'm not just changing addition, or I'm not just changing positives. I'm not just changing negatives. I change everything in the parentheses after the minus sign. Okay? That's what change is. So let me rewrite that just to reiterate. Okay, I have 2x plus 5 minus x minus 8. So I change, make it a -x and a positive 8. Now that I have addition, I do it just like I did on the problems above. So 2x minus x is a single x left. 5 plus 8 is plus 13. Okay, you guys do try these A and B together with your partners. I'll give you a quick 2 minutes. Okay? Do A and B with your partners. 1 minute each. Go ahead. Okay, that was your quick 2 minutes. Go ahead and check on the board. I know we're kind of hurrying. We kind of got pushed behind from the fire drill, so Check your work there. Any questions? Notice on A, I change everything after the parentheses. They're both negative, so I change them both positive. Notice on B, I change everything after the minus sign in the parentheses. They're both they're both positive, so I have to make them both negative. Any questions? Okay, let's ramp it up a notch. Flip over to the back. It is super important, guys. Right on the back side, you keep addition and subtraction on one side of your brain, multiplication and division on the other side of your brain. They follow completely different rules, okay? The front side, we were just adding and subtracting. Now on the back, we are going to both multiply and add and subtract. So you have to keep your rules right, okay? All right, so starting with multiplication here, up at the top, what is a different way for me to write 3 times 3? 3 squared, okay? So when we multiply, sometimes we get exponents. So what about x times x times x times x? X to the 4th, because there's 4 of them, right? So x to the 4th. So watch what I do here. 4x times 3x. Well, 4 times 3 is 12. X times x is x squared. Let me take it to the flip side for you. What's 4x plus 3x? 7 what? X, right? So 4x plus 3x is 7x. 4x times 3x is 12x squared. So you see, we have very different rules. We have to be careful. When we're multiplying, we don't even have to have like terms. Okay? When you're adding and subtracting, certainly you do. When you're multiplying and dividing, you don't. So 7 times negative 2 is negative 14. X times x is x squared. And y squared comes along for the ride. All right, let's look at a couple examples where we kind of mix this up here. Okay, example 3 and 4. So example 3, notice, it's not that there is a plus sign in between. It's not that there's a minus sign in between. I have an 8x sitting right in front of the parentheses. That's when I know I have to distribute. Okay, so I am taking 8x. And what operation happens with distribution? Multiply, right? So I'm multiplying 8x into both pieces. So 8x times negative 5x. 8 times negative 5 is negative 40. X times x. What is x times x again? X squared. Okay, and then 8x times negative 9. 8 times negative 9 is minus 72. And the x stays. Is this problem done? Can I combine anything? I see they both have x's.
No.
They don't have the same exponent, right? So even though these both have x's and you're tempted to say you can combine, they do not have the same exponent. This problem is done. So be careful. You see where it becomes important when I say keep adding and subtracting on one side of your brain, multiplying on the other side. Okay? All right, so example 4, let's mix it all up. I'm going to give you 10 seconds with your group. Decide what needs to be distributed in the first step here on number 4. Okay, I hear very few right answers. I hear 3x. That's way too far away from the parentheses to be distributed. I hear 2. It's not quite right. Negative 2. Got to take the sign with it. Okay, so I'm taking my negative 2 into the parentheses. 3x squared is just going to hang out front. Okay, so negative 2 times 4 is a negative 8 or minus 8. Negative 2 times negative 1x squared. Remember that 1 is a placeholder there. So negative 2 times negative 1x squared is a positive 2x squared. Is this problem done? No. This one is not done. I do have like terms I can combine. Be perseverant. See the problem through to the end. 3x squared and 2x squared makes 5x what? Apples and apples make apples, right? I'm not changing the exponent. So 3x squareds and 2x squareds make 5x squared. Multiplying is different than addition. You got to be careful, okay? And then we have the minus 8 at the end. Okay, sorry, but we do not have time for the try these. We need to get to homework, okay?